Now, last month, David provided that new dimension when he spoke about the power of words in the life of plants. These are some of the scientific experiments he shared with us. I'm paraphrasing David, so, okay. When plants are subjected to extended periods of absolute silence, they tend to do less well than when sounds are present, okay? They don't do well in silence. When plants are exposed to recorded or electronic sounds, they tend to do better, okay? Regardless of whether the sounds themselves are pleasant or unpleasant. It's pretty interesting. It's just sound, okay? But when plants are verbally praised or affirmed during the growing cycle, they frequently thrive in a visible, measurable way. And when plants are verbally abused or condemned during the growing cycle, they often become stunted and sickly, okay? So when people speak to them, that's when they change. I'll let you reflect on what these experiments suggest about the life of plants, but I want to share some additional science while you do that, okay? A couple of days ago, I discovered a really interesting short video.
Anesthetist Monica Bermelin is about to perform an unusual experiment. Her patient today is a houseplant. The slightest touch makes its leaves spring shut. Normally, that's a defense against insects, not hospital staff. The anesthetist is going to try to stop the mimosa's signature leaf movement. She's giving it a drink of ether, an early knockout drug used in humans. After an hour, it's time to test the result. There's not a flicker of movement. The mimosa seems to be out cold. In humans, ether works to stop nerve cells from transmitting signals. But a plant has no nerves, so why does the ether work? The answer might lie elsewhere in Germany, at the University of Freiburg, where Professor Edgar Wagner is conducting an experiment on electricity. It was long thought that plants do not use electrical signaling, but that thinking has changed. Professor Wagner will demonstrate how electrical signals pass through a plant. Electrodes connect the plant to a computer, able to record the faintest of electrical signals. This plant is in for a shock. The professor burns a leaf. And the computer comes alive. The injured plant is producing a definite electrical signal. A 50 millivolt charge races across its body and down its stem, passing through the same tiny tubes as its sap. It surges forward like a human nerve signal, though the signal moves more slowly than it does in humans. The plant shows a definite electrical reaction to the flame. Likewise, with the mimosa, tests suggest that electrical signals are what trigger the plant to flinch. When the mimosa was treated with ether, it stopped transmitting these signals and went to sleep. These are just two examples of electricity in plants.
Pretty interesting, eh?